Hey, welcome back, everybody. Jeff Frick here, coming to you from the Humanoids Summit 2024. It's the inaugural version of this show, happening where else but the Computer History Museum in Mountain View. And there's really a great buzz. We were just talking about the energy that comes from first-time shows. We're really excited to be here. And as soon as I heard about this show and I talked to the organizers, I was like, there's one person you need to make sure is involved in this whole thing. And we're really excited to have her here with us. She's Andra Keay. She's the managing director of Silicon Valley Robotics, and she's also been acting as kind of MC and moderating a bunch of panels and queen of all things robotics in the Bay Area. So Andra, great to see you.
It's really great to be here, and I'm so pleased you're here as well, because you're doing such a great job now, shining a light on a lot of the interesting social implication areas of robotics. How are we using it? What is the impact on labor, on everyday life? And one of the panels that we had today that I'm really pleased we got up there, we're talking about what are the topics that normal people want to know about robotics, because usually we're in the world of robotics startups and it's all about finding product market fit and getting to investment, or more mature companies, slightly more mature companies, and it's like we need to tune our market statements and we need to reach out to our market and we need to understand the language of our application area. And there really is no spot in the entire robotics in the entire robotics life cycle where there is let's talk about every person, or let's look at it, maybe how do politicians know what they need to know about robotics? Actually, I think that this is the one area that I think that Silicon Valley Robotics has not achieved what we would like to do, which is create greater connections between the robotics technology that's happening in the Silicon Valley area and what the politicians in Washington or Sacramento know about what is happening in robotics, because the most innovative robotics in the world is being developed right here. People think that China is suddenly running the world when it comes to advanced robotics and humanoids in particular, but most of the key development was here in the USA, and the commercialization of robotics, real commercialization, is happening here. China has its great strengths, and I love a lot of the companies that come out of there, and I love the researchers, but it is not an overwhelming force. People don't know as much about the robotics industry here as they should do.
Right. Well, Agility Robots was up on stage, and they come out of Oregon State. I mean, not the biggest academic institution.
Manufacturing here.
And they're doing it, right? And they're doing it.
And Aptronic has come out of Texas, University of Texas, and they are manufacturing here. Sanctuary has come out of Canada and the USA, and they are manufacturing here. Figure is announcing all of their manufacturing plans, and they're manufacturing here. Tesla's Optimus Rex, it's going to be here. And there are a number of newer companies coming through that are able to sort of stand on the shoulders of giants, and they're able to leap straight into the humanoid robotics industry because of all of that foundational development work. And when I say foundational, it's establishing things like the start of the development of foundation models for robotics as well.
Yeah, and even I was very surprised at the European presence here, but pretty much all the CEOs I talked to from France and Norway and these places are also setting up, their Bay Area location, because there's such as you say, there's such a concentration of smart things going on right here.
We were the landing pad, actually, for 1X when they were still Halliday. We were the landing pad for Roboy when they were coming over from Europe to demo for Google, And when you bring a robot overseas, you kind of need to have a robotics hardware space to reassemble and test as well. And we know that Engineered Arts with Amica has set up here, and Enchanted Tools is talking to us. A lot of them are realizing that one of the best opportunities to land and expand is here in the Valley, and it's because we are really seriously looking at how we incorporate AI, and the growth of the interest of the large companies that are doing AI hopefully is going to help invest talent, research, development cycles. It might not be investing money, but you can invest a lot of other very valuable things into the robotics ecosystem. And the fact that we're finally starting to bridge that gap between big tech and robotics, that's exciting.
So let's get into some of the big themes that came out of the last couple of days. And I just want to, we've sat down a number of times at Circuit Launch and at the Berkeley event, and one of the conversations is always general purpose versus purpose built. And I know you're a big fan of purpose built. And here we are at Humanoids Summit. You're like helping run this show. What's your take now? This is a little bit more general purpose than I thought you would be so excited about. I mean, there's a lot of exciting things going on, but as you kind of take a step back and looking at it with all the advancements, have you changed your opinion, or you just have these things moved along a little bit further than we think?
I think that there are layers. Like an onion, there are layers inside that question. And the majority of people that talk about general purpose humanoids, like the people that talk about AGI, it's just hype. They're blowing smoke. There are some serious attempts at general purpose, but they're being a platform for something else. And it was interesting with the panel with Jim Fan, where he's talking about Project Groot is aiming to be a generalizable model for robotics. And the others on the panel were talking about how you needed to have very specific application areas. But what we're seeing is that you are getting the best results by taking general models and then specializing them. Now, your commercial success for a robotics company is going to be primarily from a specialized purpose. And that's going to, I think, be the dominant form of commercialization for humanoid robotics companies for at least 5 years. The companies that say, and that get investment as a general purpose humanoid, it's not because of the work that they're doing. It is because of the unseen work that they're doing in data collection and developing models. So it's not what you're really thinking of as a general purpose robot. And I love that that is a viable commercial direction for robotics companies. It's just not doing all of your housework, really.
Right.
It's developing the ability for more robots to do more things in the future.
Right. Another huge topic here was the impact of ChatGPT, large language models, foundational models, and how that's really changing the way that computers can be trained now. Then somebody tried to sit down and really think through all of the steps in a process between telematics and showing it video and different ways to train robots. What was your take on that whole theme? Because that was a pretty big theme.
It is, but I think everybody in robotics knows that there is a big, big gap between what large language models can do on two-dimensional data, on digital data, effectively text and video-based data on two-dimensional screens, and what robotics needs, which is three-dimensional time-based data that is in the external environment. And I loved one of the phrases that came up before, that right now robots are still at the stage where they're just having a conversation with the ground and with objects. They're not yet engaging with the whole world. And so that just points to how far we have to come. Ken Goldberg and one of the other speakers were sharing their slides showing the difference in person hours and data size between the ChatGPT models and the largest of the robotics models. And robotics is orders of magnitude smaller in terms of data size than what has been successful in the large language models. Now, there's a whole stream of multimodal models and all the rest, but really we all know that there's a limit to how far you can go on two-dimensional data. And there are limits to how far you can go on simulated data, using videos as training data, and teleoperation for human data. And we saw some great examples about that. And the example being, there is a Venn diagram between what a human teleoperator can do, what a robot is capable of, and where that actually overlaps. So you can see that teleoperation only covers a certain amount. And the same way, simulation often fails through, I love the term, friction with reality. It is really great until it's not. And that can be a disaster when you're training models.
So great points. I remember that, yeah, because they showed maybe a bit of agility where it showed the thing get up off the ground after they tripped it.
Exactly.
And the way that it got up the ground, you or I would never have come up with that sequence of motions to get off the ground that way. So really illustrative example.
And that's where, what I love about humanoids is the non-human capabilities of humanoid robots. And way back in the DARPA Robotics Challenge 2015, I was really cheering for Robo-Simian, which was the NASA had two robots in there, the Valkyrie and Robo-Simian. And there is some beautiful footage of Robo-Simian effectively cartwheeling its body to get out of the car and open a door. There was no orientation of those four limbs and sensor kind of mode that stayed in a human type, like these are legs, these are arms, this is head. It just used whatever it needed to use, when and where it needed to use it. And we saw that in Sean Azimi's talk about space robotics, about robots that were utilizing zero gravity and their unique abilities to have very, very different morphologies.
Yeah, it's really interesting. Okay, another big topic that's here is safety. So in traditional industrial use case robots, right, they're rigid and they're stiff and they move very sharply because they have to have super precision as to where the point is for the tool to accomplish the task, and they're roped off with yellow tape and all kinds of stuff. Contrasting that, for a lot of the humanoid robots, a market opportunity is in home care and elderly care, a big kind of market opportunity. We've seen a lot of really cool examples, but the safety obviously is a lot different. These things are big and they can be heavy. They can fall down. We have one that's been falling down behind us most of the last couple of days. Yep. So when you think about safety and the difference in safety requirements and thought process for something that goes into the home versus something that goes into a factory,
absolutely,
really big difference, really big difference.
And this is where, in some ways, the collaborative robotics movement, which was describing a new wave of robot arms as collaborative arms, well, yes, that's correct, but it's also not precise, because a collaborative robot arm can still be dangerous. And you can make an industrial robot safe by controlling its workspace, not controlling the robot necessarily, but controlling, well, at the moment what we do is we control access to the workspace because the robot is fixed more or less in what it does. But if you utilize sensing and intelligence, you can make that robot adaptable to being collaborative. And you can take collaborative robot arms and extend it a little bit further, but I wouldn't say that we are anywhere near ready for home robots yet. And this is why I like special purpose robots, because you are working in a semi-fixed environment. It's not that fully fluid, dynamic environment that homes are, or even aged care centers, where it's a little more uniform. But the reality is anywhere that people live and move is a chaotic environment compared to, theoretically, what is happening in a workplace. And so I think workplaces have got to be where we develop our safety standards. And we don't just go in there without standards. There are safety standards and there are procedures, but we learn how we need to adapt humanoid robots appropriately to be safe in those environments, and we can transition that learning across. We're also going to see soft robotics playing a greater role, and already we can see with Neo from 1X, they're incorporating soft padding on the body, whereas a lot of the other robots don't. I love that, and Toyota Research Institute, TRI, goes one step further with Punyo. They've really taken the Big Hero 6 philosophy and developed more of an inflatable body robot. So you can imagine that robot hugging someone and there being no pinch points, no metal squeezing, and no undue pressure that you can't push back against. So we're still a little bit of the early stages for that sort of robots, but there's a lot of work being done in that space.
Right. Well, you segued it perfectly. We had Aaron Prather on from the standards bodies, and he talks about the difference between laws and regulations and standards. And I know you're super involved in a lot of different organizations to help develop these standards. And it's amazing watching some research on him, the degree that they break down the specificity of the standards, the specificity of the test, the specificity of the items in the test and how they should be laid out. So it sounds like, you know, they're really hustling to try to keep up with this, because the other thing, as he said, is before they had sections on for the manufacturer standards, for the integrator standards, the installers that install these things again in a factory typically, but now they really have to think about end users as these things come more in direct contact with people. So what are you seeing kind of in the movement of the standards bodies and trying to keep up with the technology? Because it's never easy for the regs to keep up with the tech.
Well, we finally got the Humanoids study group off the ground, and if you're familiar with the standards process, you start with a study group, and the output of a study group might be white papers, it might be guidelines, it might be benchmarks, it doesn't necessarily need to be a standard. Then you go to the next stage if you think that there's a roadmap in front of you, and the Humanoid Study Group is working on developing a landscape and a roadmap, a landscape of what are the standards that exist already that have application to the deployment of humanoids. And the roadmap is what are the areas that we need to be considering the likely development of humanoids. And that might well become working groups towards several or multiple standards. And that process can take anywhere from 2 to 10 years. And if you think about the multiple, highly granular standards for the industrial robots ecosystem, industrial robots have been here since the 1960s. So it takes quite a while to develop standards. They're a tool of a more mature robotics industry. However, we need to have some forms of compliance that satisfies insurers, that satisfies commercial deployments. If you are taking on a robot installation, you want to know, am I going to be sued? How does it meet occupational health and safety? What certifications did it need, and does it have those certifications? And this is why it's really good for us as the industry to be getting in at the study group stage and saying, well, here are some of the existing art, and we comply with that. And we might not need a standard for that, because you know that is covered under law. And Ryan Kalo and the We Robot Conference do a really good job of talking about where the law already exists to provide a framework for robotics deployments. So we need to be working across not just robotics engineers and human-robot interaction and designers, but lawyers and policymakers.
Yes, unfortunately. Okay, another thing that really caught me by surprise was Jerome from Enchanted Tools. Mm-hmm. And here's a guy who's been in the business for a long time, had a very successful robot before with Pepper, and I just love the way that he approached the problem, kind of thinking backwards from the fact that we want people to be comfortable with these things in their homes, and working backwards from what are people comfortable with, and coming up with this concept of creating a character, and creating the character first. That's not a person, it's not a dog, it's not a cat, so you're not going to have misplaced expectations about the way that it interacts. It's a little bit different, but because it's a character, one is there's been many, many years of development in character development, backstories, where do they come from, everywhere from Disney doing it originally with all their characters, and then creating this opportunity for people to create a bond with the machine through this character, and it's almost like backing into the fact that you actually have a robot that can help you do things. I was really taken by the focus on thinking through the interaction when you take this thing out of the factory floor behind a safety gate and actually put it in your home and thinking about the human factors of that engagement.
Oh, absolutely. I love a lot of the interaction work that is done by researchers like Wendy Ju, David Sirkin, Katie Kwan, who we saw, who's a robot choreographer, Leila Takayama, who was at Willow Garage doing a lot of the human-robot interaction work. That was the field that I came up through. And you realize that we're building on a long history of design. And as you said, it goes all the way back to Disney animators who actually wrote the principles for robot design when they were writing the principles for creating emotion through the movement of two-dimensional drawings. And those principles can be applied to three-dimensional objects. And it's little things like use slow to convey certain emotions, and how these movements embody emotions. And we know that people in entertainment have been, either innately grasping that or studying that for a long time, but they have been utilizing that. And so taking people, particularly, I think a lot of the forerunners for this were in the design and the art world, and they were experimenting with robots that certainly were not commercial, but they were exploring modes of movement and being and creating emotion in people and getting out in front of people in a way that industrial robots certainly couldn't.
Right. No, Katie was great. We had Katie on, and she talked about movement as a signal of a biological thing. Mm-hmm. And so when something doesn't move in the way that you expect it to in a biological thing, it's jarring. Mm-hmm. Because you're worried, it's your orienting reflex, it's oh my goodness, it's a tiger that's gonna jump out from behind a rock and get me. So she talked about kind of this choreography of life and then trying to make sure and think about these new objects fitting into and using the choreography, because it is going to elicit emotion. So be active, be proactive to make sure those are the emotions that you're looking for, that you want, and not it's this strange machine that suddenly entered my space.
And this goes beyond, it goes beyond face, it goes beyond body shape and form factor, it goes beyond movement. It incorporates every modality of robotic use. There are examples, for example, in sound. So some of the feedback from people for certain robots that were being deployed in the service industry was it sounds angry because it had a particular high-pitched motor drive that was like, and people found that jarring, and therefore they attributed I suppose the robot actually made them tense in response. And when that was changed to being a people were much, much happier. And in the same way that, say, with electric vehicles, it's very jarring when you don't have anything that's indicating that it's moving or that it might be reversing. And, we've learned a lot from the design of automobiles and that sort of interaction where how do they signal what they're doing? And there have been some fantastic experiments on interaction with autonomous vehicles because we don't realize just how much of automotive behavior we anticipate from awareness of what the driver is doing. And many people, there's some great work out of Stanford where it wasn't actually an autonomous vehicle, it was a person driving in a car seat suit. And it looked like the car seat was empty because they were kind of behind this kind of black thing and their arms were disguised. They were able to drive the car safely, but people wouldn't cross the road in front of it because they couldn't establish an eye gaze to assure them that the driver knew that they were about to walk out in front of the car.
Right.
So there are so many ways in which I think it's fascinating studying how we develop effectively a code of being around how we interact with robots. And it's a long-term task. And I'm a bit of a student of the history of technology and technology adoption and technology failure, which there's a couple of great books around the adoption of the automobile. And there was a 30-year transition period, really an entire generation, where certain conventions became adopted, like pedestrian crossings and road rules or traffic lights, that didn't exist at the start of that transition period, but became an adopted norm as the need became obvious.
So I just would love to kind of get your closing thoughts. Anything that really surprised you over the last couple days? Anything that you really want to especially highlight that is a signal to the rest of the world as to what's going on here? What's kind of your last takeaways? You got to sit in on a lot of sessions, introduce a lot of people, moderate a lot of panels. You're super knowledgeable about the topic. You know most of the people. Were there any surprises that even you said, wow, this is, we're hitting another one of these kind of step function moments in what's going on here?
Okay, well, the first one is, at the start of this year, I said 2024 is going to be the year of the humanoid. And everybody said, really, Andra, what evidence do you have for that? Now everybody is saying 2025 is the year of the humanoids. Look at what's happening. And I'm kind of like, that's the evidence that I had. This has been the breakout year. And this is the year that everybody started taking humanoid robots seriously. Even if 50% of the time I get a question, it's like, hey, Andra, is this humanoid stuff really serious? And it definitely is. It's been quite fascinating seeing how this parallels in many ways the adoption curve of autonomous mobile robots, where for a couple of years there, people were like, yeah, but isn't this just hype? Whereas people that were more deeply embedded knew the number of rollouts that were starting to happen commercially. Now, it wasn't like sales figures were there or anything like that. It takes a lot longer to get that real data point. But in humanoids, this was the year that we had commercial deployments. And this is not pilot trials. I think that is a really significant indicator that we're starting to be serious about humanoids. It's very easy to have an innovation trial, a pilot trial, to experiment with humanoids, and a lot of people love that. I want to see we're getting revenue from deploying our humanoid, and we're deploying our humanoid satisfactorily. We're getting more orders for it. And this is actually the year that at least 4 humanoid robotic companies in the US have planned to start manufacturing for large-scale commercial deployments. At least 4. And we know that in China, the count of humanoids is up past 85, more like 100. There are new companies every day. Though a lot of them will fall by the wayside, but the ones that are at the top, very impressive. I'm tracking certainly more than a half dozen more local, European and particularly North American humanoid robots, and that might be the final thing. I'm learning about a new one more than every month. There are companies that don't have names yet. And once we start to see that many people attacking a problem, I think that is great, because there are problems in the deployment of humanoids that still need to be solved, but we're starting to see a lot of very, very smart people attacking those problems.
Right. I think Jonathan said the agility robots are getting paid. They're like paid employees.
Yes, they are paid
for
employees.
moving totes and doing their little thing on that conveyor belt.
And now Aptronic is also keen to say that they are commercially deployed, as is Figure. I believe Agility was the first humanoid robot everywhere, including in China, to be an actual commercial deployment, not a sponsored or supported or subsidized deployment.
Right, right. Well, Andra, thank you again. If you don't follow Andra, follow her on LinkedIn, on Substack, subscribe to the newsletter. She's got everything that's going on.
Robots and startups.
Robots and startups.
Robots and startups.
Just get her on
Substack.
LinkedIn, you'll find her.
Yep.
But really great job at the conference and really an exciting time for the industry.
I've never been more excited to be involved in robotics. I think the only thing that can top this is when we have more robots out in space. And
well, they're
that's
working
coming.
on those too, right? We saw those,
coming.
everything from space to elder care and everything in between.
Yep.
All right. Well, thank you again very much. Really appreciate it.
Thank you, Jeff.
She's Andra, I'm Jeff. We're at the Humanoid Summit 2024. Thanks for watching. We'll see you next time.